Hey everyone, hope you are all good. I'm Nur Muhammad. Today in this video, I will uh, show you my 8-bit breadboard computer simulation, which is simulated in CRUMB simulation software. So, CRUMB is a software-based electronic simulator that lets you create circuits like you would on a real breadboard. And it's perfect for designing and testing complex system like this with breadboard computer. So if you're interested in the software, then you can check out the link given in description, so you can also run it. But this is a paid software, so you have to buy it for use. You do not need to spend too much money to buy it. So you can buy it around $7 or $8. So of course this is very cheap. And I want to tell you another thing, that this is my first video and I'm not very strong in English, so if I say anything wrong, please, or make any mistakes, so please forgive me. And I am still learning, so hope my English speaking will gradually improve. Okay, so let's get started. So in this video, uh, I will tell you the different component or different part of my simulation. So like clock, register, ALU, RAM, control logic, display, and so on. So first of all, I want to tell you my clock circuit. So you can see the LED is blinking here. So this is the clock circuit. So a clock is generates some pulse, and this is very important to run our computer, because the computer perform each iteration or each calculation in a rising edge of a pulse. Okay, so there have two type of pulse here. One is asynchronous and another is monosynchronous. So in asynchronous mode, the pulse is continuously generating and it gives a continuous clock pulse. And in monosynchronous, if we press a tactile switch, then it gives us a single pulse. Okay, so yeah, this is the toggle switch that can control um, this mode. So in this time, it is in monosynchronous mode, and if I toggle this, so okay, so then it will shift it in asynchronous mode. So you can see, okay, the LED is blinking. So, and also you can see a bunch of work around. So of course it is connected the with the whole computer. So if the clock is pulsed, then the computer also started to work. Okay, and this is the hold button that hold the clock pulse. Okay, so and this is the uh, toggle button or tactile switch that can, if I press this, then a single pulse will generate. Okay, single clock pulse will generate. Then I want to tell you about the registers. So this is register A and this is register B. Okay, so a register gets some value and store in store it here. Okay, inside this. Okay, so there have two register. This is register A and register B, and these registers can store 8-bit numbers. And from this register, the value is given in the ALU part. So this is the ALU or arithmetic logic unit. Okay, so if we put something in register A or register B, then it will go to the ALU and something will happen. Okay, so the ALU is the heart of any processor. Okay, so it performs simple operation like addition or subtraction. So it takes input from register A and register B and output the result. So we can see the result by these LEDs. Okay. So, and also we can store the ALU value also in memory. So now we can tell you or we will see about the RAM. Okay, so this part, and this part combined make the RAM part. Okay, so first of all, this is the RAM address. So and this is the core part. They are our main component are here. Okay, so they have 16 byte of RAM. And for controlling the address, this is the address portion. So of course 16 byte need to 16 byte for 16 byte RAM we need to control 16 different types of address. For this we need 4-bit binary. So we know that a 4-bit number generates different 16 type of different combination. So each combination indicates a address of this RAM. Okay, and this is the actual RAM, and this is the RAM input register. Okay, so we can input something in the RAM. So for this there have a toggle button for manual input and auto input. So auto mean when we run the program. Okay, so the red LED, if when the red LED is on, then it means that the manual input is on. Okay, then we can change here the address, and we can temporarily set the value, and if we toggle the switch, then the value will store in the RAM in that address. Okay, so in a different address we can store something, anything else. Okay, so we can store here 16 different types of number. So that will very much helpful to now to our next programs when we run any program on this computer. So we will see it later. So then I want to tell you, I want to show you my program counter. So this is the program counter. So it keeps track of the address of the current instruction, and after each instruction it moves to the next address unless if we jump in another address. Okay, then we will see the control logic part. So in this part you can see there have two EEPROM. So EEPROM, I mean ROM. So one is RAM and another is ROM. So RAM is a volatile memory. That means if we cut off the power, then the all information will gone. And ROM is non-volatile. Okay, so if we store something here, then it will store permanently until we change it. Okay, so it is very important to control our logics. So the core logics are stored here. So it's control the different types of component from here and perform or run a program. So it is very it tells every part of the computer what to do during each step of an instruction using microcode. So each instruction is broken into control signals that activate the component. Okay, and which components are activated, we can see it here. So like this is memory address in and uh, counter out. Okay, so like this, it can control different parts of this computer. So now we can see this part. This is small part beside the register A. So this is carry flag and zero flag. So if a value is overflow in ALU, then carry flag will turn on, and if the result is zero, then zero flag will turn on. Okay, so this is very important. We will see it when we run a program. Okay, then at last we will see our display module. Okay, so these all are for display unit, okay, or display parts. So it's so a value, a binary value into a decimal value, so it converts and show the result in a 7-segment display. Okay, so this is the overall all parts of my 8-bit breadboard computer. So in our next video we will run a program in our computer, and hope the program will run and we can see something here. Okay, so okay, let's end here and see you in our next video. Okay, thank you.